landslide and geologic hazards. The real big use in the flood map. But it's pretty incredible how much benefit there is of this product. So I mentioned we're going to talk about where we are today. We are in this download mentality, right? We have services that show you where the data is. We have services that show you what it looks like, but then you got to download. You have to unzip. You have to do all kinds of things with it. We looked at dynamic services where a user can come in and say, I only want this, and I want to build this, and just give me that stuff. We found that it was really costly for us right now, and it also, there was a huge backup. We just weren't prepared enough to continue with that. Plus, this meant we look at this mentality, we think this is not the right way to do big data. You know, you just cause a stovepipe. We want to be able to provide the data up on a cloud somewhere where you just have access to it, and you don't have to unzip it. You don't have to. It's ready to use for processing. We have some services out there. We're building more, but once we go to this cloud, we may have to look at a different way of accessing. So where do we want to be? We want to put the data up there unzipped. We want process ready. We want to provide some basic tools for the use of that data, and then we also want it to be on a platform that enables people to build their own workflows, deal with whatever computing issues they want to solve out of that, using that data. So that is our goal. So we're starting this in 2017. We're going to take a look at putting this up in the cloud, putting this point cloud information up on the cloud in an unzipped format. We're also phasing in a handful of different services, and I have a list here. We're looking at, someone going up, looking at that point cloud data up on the cloud and producing their own DEM, their own digital elevation model, raster service models, just a way to view the point cloud and the 3D data. And we're also looking at using software, grid software, that's from the Army Corps of Engineers that we're actually working with them. So, we're also looking at the scalable computing power. So we want to be able to set it up on a platform that enables people to build their own workflow. Whatever they're after in that data provides, they can rent space, rent whatever infrastructure they need to attack that problem, and just walk away with maybe just the answer. They don't even need the data, they just want the answer to their question. So here, this is the grid tool that they're looking at. Army Corps of Engineers has built this. It's a portal to the actual LiDAR point cloud data. It's just one of the things I wanted to show that they're actually playing with right now. So current research. So this is coming out of that Center of Excellence group. So they definitely see a need for high performance computing and parallel processing. So they've actually done a little bit of this with the digital elevation model creation, where they've come across problems. I mean, the GIS data is difficult when you start talking about going to a parallel processing format. They're hitting a lot of snags there. But again, this is within the group that's working on this. They were 5 years ahead of us. They're trying to solve our problems for down the road. So this is going on right now inside of CGIS. Here's a sort of a geeky slide for you. This is Lynn wanted me to share this with you. This is the kinds of equipment that they're using right now. I cannot go into detail. So, if you have any questions about the Landsat group, talk to Brian. And if you have any questions about what's going on in the parallel processing high performance computing, talk to Lynn. He's our director. And I'm not sure if any of you have talked to Lynn about what's going on, but I certainly see some overlap where I want to make sure he's in touch with you guys. So I think that's rather quick. That's all I have.
That's some backup slides. Yeah, thank you very much for this overview. And now we have two options, questions, or let's see what he has in his backup slides.
What do I have in my backup slide? Oh, that's a part of that Landsat discussion. I'll skip that one. Yeah, there's some challenges. This was actually challenges I went to see, just like I told you in OGC there, but I didn't like the slide, so I took it out.
My backup for some.
But I think the issues are still relevant.
Maybe
Compression,
discussion.
security. Yeah.
So maybe you can mix it, yes.
I like this slide.
Chucky? Okay, 1, 2. I'm stealing the microphone.
I know Chuck has a question.
We just knew that. Chuck, go ahead.
The answer is no.
But I do like this slide. So Glenn, I do like that slide. Those are some good questions we should be asking. What could OGC potentially help?
Yeah.
And, particularly the cloud processing pipelines. Some of the things I've found is that the end product from LiDAR processing depends upon how you filter the raw input. And if you can actually build custom pipelines to filter for different types of signals, you can create very different products. So there's a lot of good stuff you've got on this slide. Don't put it in the backup.
They get a little back.
Say nothing.
You have another question back?
Yeah.
Oh, I was going to say,
Opportunity to-
thanks, Chuck. I appreciate that.
They keep on chasing me. Okay.
I'm closer.
So
So I was very curious. Wow. So I was very curious about how 1 meter resolution bathymetry is possible. Because I work in the flood modeling world, and bathymetry is notoriously hard.
Yeah.
Would you happen to know?
I don't know for a fact, but I know
Wait.
they do some,
Say nothing, say nothing.
say nothing.
No, thank you.
I know they're going to that approach. I don't know how far they've gotten with that. They do pull up some data, but I don't know if it's a 1 meter
I
resolution.
can speak to that,
Oh, perfect.
actually. No, it's okay, I'll just speak up. I'm actually.
no, you cannot speak that loud that you get those people outside.
Thank you.
Okay.
I'm Sam Fredericks with the USGS,
Perfect.
and we had the Earl LiDAR system, and it's a Togobati system, and we were actually getting sub-meter resolution, depending on obviously the environment and obviously turbidity, things like that. But in the Virgin Islands, we got down to 42 meters, and we were able to do a sub-meter resolution DIM. The point cloud, it just depends on the point density, obviously, the nominal pulse spacing, things like that, but we are trying to feed it into the national map, the point cloud itself, once we get it published as a data release, so it's citable. But it just depends on your sensor capability. The Regal 880 is coming out. A few of them have deployed it already, and that's another one that's addressing those bathymetry needs. It all just depends on the environment. Does that answer your question?
I'll follow up.
Talk to me after.
Okay. Excellent. Thank you. Now there again, climbing the hill. Sorry, there was some. Okay.
Thanks, Glenn. Could you comment on sort of interactions between particularly Landsat data and a couple of commercial entities? I know Amazon has a bunch of it now, and Esri is doing something with that, and I think Google Earth Engine has been doing it for quite a long time. Is there any thoughts on those partnerships to help out?
When you're talking Landsat, you're out of my realm.
I'm really getting my workout here.
Yeah, Landsat is not, it's not in my world in the national map, so, point of contact Brian that's up there, go for it.
Okay, there was something up there. Okay.
So, the group I run at the University of Coast. So the group I run at the University of Illinois is the one you mentioned working with Lynn on the LiDAR data processing using high performance computing and big data.
Excellent.
So for those of you who are folks, okay, so for those of you who are curious about some technical details, feel free to follow up with me on that. But I want to comment on the flood mapping side using LiDAR data. Currently, we're working in this national flood interoperability experiment with UT Austin. David Midman is spearheading that effort. We're evaluating LiDAR data across multiple resolutions from 1 meter, 3 meter, 5 meter, 10 meters to see the impact of such high resolution LiDAR, especially characterizing the topographic features to understand flood inundation quality we could achieve. I think multiple USGS colleagues are contributing to this collaboration as well as some other agencies. Again, we could follow up offline if you're curious about those details.
Does this work? Yeah. So that's a good point because the LiDAR that's being collected right now, we have a priority going to the a lot of coastal waterways. So if you go on our website and see where the LiDAR exists, you'll see a lot of coastline collected.
No, there was something way back.
Hey, so I'm just interested in the grid system. Do you know much about that? Like, is that being developed out in the open? And there's already like some platforms for doing parallel writing and reading of geotiffs. And the popular open source one in the slide, I think, would be Poodle, and I think Howard Butler is doing some really good work around that and is involved in that effort. So I was wondering if that's, do you know yourself if there's other frameworks that are being evaluated for the geotiff side of things, or if there's a point of contact?
There are.
Oh, great.
I can't name them, but they're just not focused on the one. That's just one I pulled up because it was highlighted in his slide deck. So.
Okay, is that being developed in the open, or is that something that's going to be open source?
I believe it is being developed in the open.
Oh, cool. I just haven't found it.
Yeah.
Great.
From what I understand.
Thanks.
Now, can you jump in here for a second?
Yeah, so one of the interesting things that maybe we can work on is this idea of the raw data versus the products. So there's, I understood it, the focus was on the products at first, and it came as kind of a surprise that people also had use cases for the point data.
Yeah.
But, so one possibility, for example, and the theme in all of this is, it's an old idea, but moving the processing to the data, this large quantities. So there's two things. One is connecting the raw data to these products. So for example, being able to host the grids in Earth Engine and process them there, but the point data being somewhere else and being able to link to them. And the other is that this sort of grid apportionment and things like HDFS and so on aren't spatially sensitive. So that would be a really good, things like vector tiles that are being worked on here have some applicability.
Yeah. Great points.
Thank you. So, in the meantime, okay, I'm coming down, but let me ask this cross-fertilization question, Glenn. Do you see anything that would ring a bell with you from Keith's presentation, so that there could be a spillover of technology?
Yeah, definitely. Keith, in the earlier presentation about the work that's being done with the I think if they're not already in touch, they
Mhm.
Okay, thank you.
Last and final question. So you had one, and then
So a recurring theme that we've seen this morning is that we still live with a possibly predominant download mentality about data. I'd be interested in your views on what's the primary barrier? Is there one, are there many, to moving beyond that mentality and really embracing this cloud architecture?
you're looking at me, but you're asking Glenn, right?
It's sort of a question for Glenn. I think Jeff mentioned it earlier too, and probably there are plenty of people in the audience who have a point of view about this.
That I believe is really a core question. That should get us forward. Getting away from that download mentality, you spotted it nicely.
Jeff Walters might have.
it's definitely a challenge.
Yeah, it is. I mean, and it's like I think I mentioned earlier. A lot of it is, well. Oh, sorry, Glenn.